The last lesson in this unit is about half-life. A lot of radioactive material decays using half-life. It's also how we can test how old certain elements are based on the half-life formula for that particular element. So this is a really useful formula for us to take a look at. A sub T is the amount of the material left after time. A sub 0 is our initial amount. Of course, we're using 1/2 for the base because it's our half-life formula, to the T time over K power. And K is the half-life time in years as well. Our essential question is similar to the one we've been looking at for several days, so let's get started with our half-life formula. Our first question, we're looking for what is the initial amount. I like to write the formula down so I can see exactly where I'm subbing each value in. The one tricky part of this formula, I think, is that K. It's the half-life of the element. So we're told a certain element has a half-life of 3,685 years. So that will go in the denominator of our power. There are 3 grams left. That is the amount after time, after 10,000 years. 10,000 is our T. And the question is, what was the initial amount? So we're solving for A sub 0. In this case, all we need to do is divide both sides by 1/2 to the 10,000 over 3,685 power. You can let your calculator do all of this work for you. When you use your calculator, make sure you put parentheses around that exponent so it knows to divide the 10,000 by 3,685 before it becomes a power of 1/2. I got about 19.680 grams for my initial value. And our second question is how much will be left after 20,000 years. This time we're solving for the amount after time. We know the initial amount was about 19.68. 1/2. The element has been decaying for 20,000 years, and it has a half-life of 3,685 years. We can just punch all of this into our calculator. Let your calculator do the work. Your calculator knows order of operations. The only thing you need to be careful of is that exponent. Put parentheses around it. You want it to divide before it raises it to a power. And I got about 0.457 grams of the material will be left. Our next question, again, I like to set up that formula first, substitute what I know, and solve for what I don't. It says an artifact containing an element with a half-life of 2,500 years, so that'll go in for K, has 35% of its initial amount. In this case, we're not told what the initial amount is, we're told the percentage that's left. So it doesn't really matter what we choose for our initial amount. I like using something like 100, especially when we're given a percentage, because if we had 100 grams to begin with and 35% remain, we have 35 grams left. You can choose any initial amount you want and calculate 35%. It's sure a lot easier to start with 100, however. And our variable is T. How long ago was it made? That's what we're looking for. Our first step in solving when the variable is in the exponent is to isolate the power. We have 100 times, so we're going to divide both sides by 100. And of course, use logs to solve when the variable is in the exponent. So I'm going to take the natural log of both sides. You can use the common log. If your calculator has log base, you can just convert the exponent back into log form. You would have a base of 1/2. Of course, that's helpful because we can turn that power into a coefficient. We'll have to divide both sides by natural log of 1/2. And we will have to multiply by the 2,500 to get it out of the denominator. Again, let your calculator do the work for solving for your variable. Rounding to the nearest year, I got 3,786 years. That's half-life. So here you have a U-try question. Just make sure you set up that formula so you can substitute the values in the right spot.